All right, congratulations, everybody. Thank you for sticking with me to the end here. This is our final session in the boot camp. Now, there's obviously tons more topics and aspects to manufacturing, which you could talk about forever. But to put an end cap on this, we're going to talk today about some additional considerations as you scale your product or your production. And this will include certifications, labeling, distribution, and then we'll talk a little bit about software and funding stuff too. So for those of you who don't know me, my name is Matt Verlinich. I work for InnovationWorks hardware team, and I manage our manufacturing initiatives. I am also on the team here with Jesse Mazzoni, who manages Alpha Lab Gear accelerator programming, and Mike Formica, who manages all of our hardware initiatives. So this program is based on the NextCore Manufacturing Accelerator Program, and they are our sponsor for this program. They received funding from the National Institute of Standards and Technology, through the MEP network, the Manufacturing Extension Partnership. And this is a group of manufacturing support organizations, nonprofit economic development organizations who support manufacturers in the United States to try to help them improve their business so that they can be more effective working with U.S. companies and improve the economy. It was also sponsored by NYSTAR, the New York State Division of Science, Technology, and Innovation, similar to the Ben Franklin Institute that we have here that sponsors the InnovationWorks, as well as the other three Ben Franklin networks, the other corners of the states. This programming is based on a collaboration of resources from Rochester Institute of Technology, Fuse Hub, which is New York statewide MEP, Catalyst Connection, which is the MEP for Southwestern Pennsylvania, and InnovationWorks. So some of the Alpha Lab Gear programming, as well as my scalable innovation programming. So as I said, this is week 8. I'll go over this again in the homework, but we're talking about considerations for scale, as well as some project selection, execution type stuff. So recap this. Remember, there is on the scalableinnovation.org website, there is a manufacturing bootcamp page now that has the recordings of all of the past presentations. I'm going to leave those up there in perpetuity. So if you ever want to go back and reference them, you can. They are also, the curriculum outline will also be there. So you can always go back and reference the content for this curriculum. In fact, I'll probably be just adding to it and refining it over the time. It also has a list to all of the surveys for each piece of curriculum. So if you do go back and find anything particularly useful or something glaring that's missing from any of that content, please fill out that survey and let me know so that I can continue to help make this curriculum more useful for startups like you guys. A total summary of all of the homework assignments that we've covered. This is all, this is in that course outline, but I figure it's a good opportunity to recap it here in person and to let anybody ask any questions if you have them. So we have in the first session, we talked about customer requirements and product specifications. This was ideally captured in a product requirement document, which would be that high-level summary of what your product is, that can then connect into all of your other technical specification or your other technical documents, like what we covered in session 2, the bill of materials. So the bill of materials is your component list of every part that goes into your product. And that's where I would capture specifications for each component that goes into the product, as opposed to the specifications for how the product performs as a whole. The companion to the bill of materials is the bill of process, which is the sort of written out step-by-step instructions portion of a recipe, whereas your bill of materials is the ingredients list in a traditional recipe. These documents are going to evolve over time, and you might have different formats for them for different types of purposes, like what we covered in session 5, the design for manufacturing, design for assembly, and design for other types of variables like sustainability, environmental impact, maintenance, etc. That would be a critical thing to get your bill of materials into, for instance, a format that would allow you to sort by the percentage of the total BOM cost, so you could identify if there's any particular component that results in a significant opportunity for cost reductions if you could optimize the production of that part. This in session 3, we talked about cost and risk management, where we covered cash flow forecasting as well as risk tracking documents, and how these can relate to, again, sort of your DFM optimization analyses, all through using your bill of materials and bill of process, so that you understand, either what represents a significant economic risk or a significant technological risk that would warrant you doing a deep dive analysis of that particular component. In session 4, we talked about the intro, like an overview to quality and what it means. In particular, we emphasized a prototype quality test plan. So this is a basic quality document that would allow you to sort of identify what you needed to identify, or what you need to learn from a particular prototype and how you intended to learn it. Very useful in setting specifications before freezing a design and moving on to another, like the next scale of production. In week 6, we talked about working with manufacturers, including how to identify, categorize, find different potential partners, and then also some checklists for what to do when you visit a supplier or onboard a supplier, and how to maintain, manage that relationship. Last week, in week 7, we talked about the quality, overall production quality and certifications. So this was a greater emphasis on methods of quality assurance and quality management systems that are present as you scale up and utilize either a contract manufacturer or scale your own production, more so than just the individual testing of a prototype. Also talked about the failure modes and effects analysis, or FMEA, and process control plans for how you would intend to maintain a quality production over time. So that was a lot, but it's all summarized in the curriculum outline, which is linked on the Scalable website, also linked here. But in column K, I'd appreciate if you filled out any feedback you have on any of those topics, if there's anything you felt we didn't cover. And then in column L, if you didn't end up getting the chance to attend one of these sessions, or if you ended up going back and watching it again, please click the link in that column and indicate if you watched it. Now that the program is wrapped, this official boot camp is wrapping up, my office hours will always be available. So if even down the line you want to review something, feel free to put some time on my calendar, and I'd be happy to go over it with you. Here's just a brief list of some of the things that I might be able to help you with. So today we're going to do a deeper dive into certifications and labeling, which is really important as your product scales and starts to get more and more users out in the public market. We'll talk about distribution, which is oftentimes a very complex step to scaling, and some of the challenges and opportunities around distribution. And then we'll talk about sort of roadmaps and project selection on how to identify, define, and work towards specific projects for growing your business or your product. So last week, we sort of gave you the action item of coming up with a quality mission and a failure modes and effects analysis and process control plan, at least starting on it. These are huge documents, and you might not be at the stage right now to be really fully defining these, but I think I can't underestimate or I can't overstate the importance of at least creating a placeholder document and making sure that it connects in to an overall product management picture of your product. So I highly recommend that. Did anybody take the time to put down any thoughts in a failure modes and effects analysis or process control plan? Mara, you don't count because you have to do this by law, and I know you already have probably all of this stuff done. All right. No worries. We can move on. Yeah. So certification and labeling. We talked about this a fair bit last week, but we're going to do a bit of a deeper dive. So recap on some of these terminology around this. We throw these words around, but I think it's really good to have some context behind them. Regulations are, in fact, laws that are set in place so for different industries or different markets, different product types. A CFR stands for Certified Federal Regulation. It is a federal law. There are different types of regulations that might be different depending on the country that you operate in, the state, or even the local municipality. But the federal regulations are the big ones that we hear the most about. There are then organizations like ISO, which is the International Standards Organization, that set standards which different suppliers or products might meet in order to comply with those laws, the regulations. The standards themselves are like a checklist, and sometimes they're private, sometimes they're public, but you can look them up, and there are ways around it where you can get an idea of what is involved in those. However, depending on the type of certification or the type of standard that you're trying to meet, it might be a certification that needs to be maintained by your manufacturer, like ISO 13485 is a standard that is put into place so that manufacturers would comply with a set of a quality management program that the FDA, who is a regulators enforce regulations, and they look for certain standards in order to make sure that it's actually in compliance with their law. So ISO 13485 is a great example of one that contract manufacturers will maintain if they have a quality management program that is approved by the FDA to meet. I don't remember what the specific CFR is, but actually I think it's on the next slide. Now, another aspect of that, which is a little sort of complex nuance, is that there are different certifications and standards which are meant specifically for products. So if your product is compliant with a particular standard, you might be able to carry a certification on the product. And in order to carry those, it's oftentimes not enough to meet this standard itself. You have to have it tested by a nationally recognized testing laboratory in order to meet that certification. So a great example of that is UL, Underwriters Lab. If you need an Underwriters Lab certification, the only person who can actually do that testing and certify that your product meets their specification is Underwriters Lab. Now, I can't remember, I think there's 9 nationally recognized testing laboratories, including these 4 big ones that are listed here: UL, TÜV, Intertek, and CSA. Now, you've probably recognized these labels because they're oftentimes on the bottom of every consumer electronic product that you would get out there. So basically, the only person who can stamp a product with one of those labels is somebody who has actually submitted their product to that organization for testing to meet a specific standard. And, this is the slide that I had created specifically for medical devices, and I think it's a really great best practice to try to aspire to, even if you are not a medical device. So the design history file is that version controlled set of documents that embodies everything electronically that you need in order to describe what your product is and how it performs. Your device master record is all of your sort of SOPs and how to build the product in a way, build a product and test the product to make sure that it performs as your design history file outlines. And then your device history record is a record of everything that you've ever produced, every single individual product that you've produced, who produced it, was that person ISO 13485 compliant at the time that it was produced. All of that information is contained in a sort of device history record. And ISO 13485 is a certification that meets this standard 21 CFR Part 820, which is a law enforced by the FDA to make sure that anybody who manufactures a medical device is up to their standards. All right, welcome, Dylan. So, a review of certifications. Here are some really great questions to ask yourself whenever you're trying to identify what certifications you might need. So, number one, what are you selling? What's the technology, the underlying technology? What's the functionality? Where is this going to be installed, or who is going to install it? Number two, is the product regulated? So the way that I think about it is it goes sort of top of it is medical and nuclear, then aerospace, then transportation, then food, and then below that is sort of consumer products. And those are the sort of tiers of regulation, and sort of the highest regulations down to the lowest. Now, you might be subject to regulations even at the lowest levels of that, but who is going to come enforcing them, it just it's lower probability the lower you get down the totem pole. Really important on the third point here is to ask, who is your end user? And are they young children? Are they a vulnerable population? Or just in general, does the use of your product potentially put somebody in danger? It's something that's really interesting because, generally we don't think about a car being that dangerous, but the fact that when somebody operates a car, it can be very dangerous. That is one of the reasons why the transportation has its own sort of whole level of regulations, that it focuses on the specific use of motor vehicles and the operating environment of motor vehicles. Another really good question to ask yourself is, where are you selling it? And this is something we covered too. CFRs are certified federal regulations, but regulations can vary from state to state or even down into local municipalities. They definitely vary country to country, and they can even vary country to country within the EU. But in general, the big ones are, North American market, between the US and Canada, and then the EU, which covers most of the countries in Europe. Another really important one is, what channels are you using to sell? So some distributors and retailers will require UL certification in order to even be listed on their website or to be sold through their brick and mortar stores. And this is a really interesting one, where we talked earlier about the arms race sort of between CE, which is Centrale European, something like that. It's like a European UL basically. And they have very comparable standards to everything that the UL has. However, oftentimes American distributors don't recognize CE marks. They only want underwriter's lab marks. And then the opposite is oftentimes true. You cannot import something into the EU without a CE mark, theoretically, if you get caught by customs, let alone distributors. So certifications required for your product will also depend on how are you shipping it. So this can be everything from batteries and specific restrictions that are in place for selling or transporting on airplanes, but also getting it into a country through a shipping port. It's necessary in the documentation that you would have to file with getting it into a port to indicate whether you have a CE mark, for instance, in Europe. There's also important requirements about where your product is manufactured. And this can be anything. For instance, in order to get a product out of China, it has to be labeled on it that it was made in China. They will not let it leave the port in China without that sticker. So that shows you why there's that sticker is prominently displayed everywhere. I'm not entirely sure of what labeling requirements there are around being able to say made in America. I know that there's been a lot of discussion around that and whether something is actually made in America or not, and it depends on who you ask. I know that the DoD has sort of the highest levels of that, where especially for defense critical applications, they cannot buy anything that, even down to the component level, that wasn't produced in the United States. Another critical question to ask is how much are you selling? So some regulations apply only to high volume sales. And also, if you go to an underwriter to get insurance for your product, they might not necessarily, especially in the consumer market has a lot wider of a gray area in terms of what constitutes public health and safety. So if you're only selling a handful of products a year, you might be viewed as a far lower safety risk to public health and safety than if you're selling millions of products. You sell millions of products to the consumer market, you can have a very small risk to health and safety, which could constitute a very large public health risk, which would cause somebody to come after you. So very important to keep in mind that might change over time as well as you scale. Another really critical question is what materials are in your product. So lead paint is a great example of that. Lead is one of the biggest ones and has gotten the most attention ever since the 70s and all of the international EPA lead mitigation strategies that were put into place. But there's other like toxic heavy metals in particular, like chromium, that have specific restrictions on them. We've seen a lot more like BPA, biphenyl. I can't remember. They're plasticizers. So anything that's made of plastic can have plasticizers in them that are now starting to be subject to, if not actual regulations, they can be at least customer scrutiny. So consider what you're making your product out of. Now, breaking it down further into different types of certifications, a good way to think about how certifications might chunk together is, does your product have an electromagnetic field associated with it? Now, technically, any product has any product that has batteries or plugs into a wall emits an electromagnetic field, but there are different levels of power and different levels of frequencies that come out of it. And so the FCC regulates all of that in the United States, and CE regulates all of that in the European Union. Safety, this is a general catch-all, and it kind of goes back to a lot of the things that we talked about before. There are certain industry requirements around safety, like the Department of Transportation, or the Department of Defense, or medical devices. And they're regulated differently depending on what industry you're in. And there's material requirements. This is an important one for import, export, and logistics. So this is especially the case around batteries for transportation, but I doubt anybody here is working with radioactive elements, but that is another potential source to consider. Even very, very small radioactive elements, like the ones used in smoke detectors, if you get over a certain size, can be regulated. Environmental certifications are another important one. This kind of is tied to the material side of things. You're probably familiar with RoHS, and you'll have seen that logo stamped onto circuit boards because it was very, very common that lead solder was used for most electronic circuit boards. And so RoHS is a law that was actually put into place in Europe that most of the rest of the world has conformed to, and it is sort of a certification held by a factory to indicate that they can produce a board that they not only certify won't leach lead into a person or into the environment, regardless of how it's disposed of, but also that they, as a manufacturer, won't leach lead into the environment as a result of their manufacturing processes. So it's a very big catch-all sort of regulation around hazardous materials. Chemicals are another one too. California Prop 65. So this product causes cancer in the state of California. Well, that was a law that was put into place. Prop 65 basically states that if your product has a list of, I think it's over 100 different chemicals in it, if it contains or might contain any one of those chemicals, you, in order to sell it in California, have to put on your label that this product might cause cancer, according to research done by the state of California. That's where those Prop 65 warnings come from. And even for Amazon, whenever I first started selling on Amazon in 2017, they did not require Prop 65 warnings. But now, if you want to sell on Amazon anywhere in the country, not just California, they make you have a Prop 65 requirement on it. There's also recycling codes, which is a form of environmental regulation and labeling that is something that I personally overlooked with my product and would like to rectify someday. Other types of certifications which we don't realize are communication protocols. So Bluetooth is actually a communication protocol which is regulated by that corporation. So in order for you to say that this module is Bluetooth compliant, it technically has to be certified by that corporation. Most people use pre-certified modules, so they never worry about it. But if you built your own Bluetooth module, you would need to actually get it tested. Same thing with Zigbee. Then industry-specific requirements, we talked about that with FDA, aerospace, FAA, and then automotive and TSB. Exports, this is something that you'll see if you go to a lot of manufacturers in southwestern Pennsylvania even will have ITAR compliance listed as something on their website. This basically means that they do defense work, because in ITAR compliance means that you have certain security protocols in place that if something of a top secret nature was manufactured in your facility, that critical design information would not be leached anywhere else, and also that you don't traffic in arms or weapons that could be used by terrorists. So you don't accept money from terrorists, and or you don't sell any of these products that you could theoretically make to terrorists. And then there's a lot of voluntary certifications out there, like fair trade, which are basically competitive differentiators for your product or your company. So how do you select certifications given all of this information? There is a number of different ways, but here are just a handful of little strategies that you might use if you're not sure where to start. So you can look at similar products, similar markets, users, industry groups, and features, and see what certifications they carry, what labels they have on their product. You can look on the Consumer Product Safety Commission's website. This is an organization which basically compiles recalls for consumer products. And this is a great way to figure out if there was a recall or if there was a lawsuit because of some type of harm that came to the general public through a consumer product. They will catalog all of that information on their website. You can call different certification labs. That can be third-party independent labs or nationally recognized testing labs. And you can get quotes on what it would take to certify your product as being safe. And they have probably the most experience of any type of organization in working on that. But your quote and their recommendations for you are only going to be as accurate as your product requirements document is. If you don't identify specific use cases or specific customer segments or locations where your product might be used, then they won't be able to make the appropriate recommendations for you. So coming back to the PRD and why it's the first session that we cover, it is extremely important. So now you can also talk to your contract manufacturer about it, or any supplier that you're working on, especially if they've made a product that is similar to yours. Highly recommend asking any contract manufacturer that you're trying to get a quote from if they've made a product similar to yours, and then asking them what that product sought as their particular certifications or quality management systems to, ensure that their product was safe. I would also recommend talking to an insurance underwriter, because ultimately the way that you protect yourself from any potential liability or harm that would come to your end user is through your insurance policy. And if you can't get somebody to actually insure you, regardless of how many certifications you have, you're going to still have to carry the full weight of any lawsuits that come out of the use of your product. So I highly recommend talking to an insurance underwriter. The answers that they give you are going to be based on their perspective and their experience. So you'll also want to make sure that they have experience insuring similar products that are used in similar environments and with similar customers at similar scales, because the answer that they provide will also be sort of dependent on what's the total potential harm that your users might come to. That will be different, again, if you have 10 products in the field versus 10 million. There are also certification consultants out there who specialize in this specific type of risk analysis and mitigation. I will say that might be harder to find in the lower regulated industries like consumer products. However, in highly regulated industries like the FDA, there are absolutely plenty of professional consultants who can provide you with an analysis based on a lot of extensive experience, far more than I have. So I would trust their word for things over mine for sure. And then the last bullet here is the one that I would recommend the least, which is to learn about the laws themselves and the governing bodies around your product and area. That can be a real minefield of a deep dive. It'd be very difficult for you, especially if you don't have a legal background, to decipher that. However, there are different industry groups around specific types of use cases that would probably have a lot more free resources to help you digest that ultimate information. Now, what if the required certifications are unclear? That is the $1 million question, or the $10 million question. That will almost always be the case, except in the most highly regulated industries, there will be ambiguity in that. And what the only answer that I can really provide you is that at the end of the day, it is up to you to consider the cost versus the potential risk. There's a great fight quote or a Fight Club quote about that, but I will not read that one to you. Basically, it comes down to you have to multiply the cost of failure, the total number of potential failures that are out there in the world, and then assess whether or not and the probability of failure, and assess whether the total cost of a failure is greater than the damage that you would ultimately do if you don't issue a recall. Right. So this is one thing that I think would be valuable to stop and ask the group. I'd love to get a gauge for where does everybody stand in their certifications and the understanding of what certifications you're subject to, what regulations you're subject to.
I can talk a little bit about that, Matt, since we just talked about it yesterday. So we're making a heating system. So and it's a smart heating system. So the two certifications that we know that we definitely need to aim for are UL and FCC. And the way we have decided to go about this is it's cheaper to get some of these certifications done outside. And for UL, it doesn't matter which country you do it in. It's as long as you're certified everywhere. So we have looked at UL India as an option that will get us done for a lower price. And we've discussed with them, and it seems like it'll take about 3 to 6 weeks once we have the whole product together. And then FCC is a little bit of gray area for us right now, but that shouldn't be too complicated since we're not making our own wireless emitter. We're just getting something off the shelf.
That's awesome. Thanks for sharing, Rohan. I didn't know that UL had an India branch, but that makes sense because like the UL database is really what you're trying to become a part of. So if they perform the test to their standard and you get listed in their database, then you have that certification anywhere that UL is recognized.
Right. They have UL in all the countries, I think, or most major countries.
Good to know. Stephanie?
Yeah, so our product's similar, UL, FCC testing. We're probably going to get CE marked as well. That's a great tip about India, so thank you. Our testing lab was actually the one that reviewed our product in detail, recommended what tests we should complete, understood the nuances between our device, which is a consumer device, and a medical device. They were just really super helpful. Gave us a whole test plan of what we need to get done, and their turnaround time is like 2 weeks for our stuff. So aggressive too.
That's awesome. Yeah, we'll talk about this a little bit later, but in terms of the FCC requirements, I know that a lot of manufacturers will do rudimentary FCC and electromagnetic interference sort of pre-scans because they have a good understanding of, or they know what the standards are and what will be tested to. So I think the FCC only recognizes testing from specific testing labs in order for you to actually get your FCC certification number. But the expense of doing that can be mitigated if you were sort of pre-certified, and a lot of manufacturers can do that for you if they have the experience. So something that's useful to ask depending on where you're getting certified. Go for it, Mara.
Yeah, I'll share. So we're a medical device. So obviously we have to self-certify to 21 CFR 820, which is basically the FDA code of federal regulations, and everything that comes under that. In addition, as part of that, we also have to do a lot of the ISO testing for electrical safety, because we do have electrical components for ours. So similarly, we've done ISO 60601-1, which is the safety, 60601-2-18, which is the EMC. A lot of those things that are probably similar to the rest of you guys. We had external labs do all that testing. I'm happy to share quotes from that if anyone is interested in seeing how much we paid for those certifications. One thing that I was surprised by, if anybody else has to go through the ISO 60601-1 testing as part of their, UL or anything else, is that they want your whole risk management file. So they wanted to see all of our risk analysis and risk mitigation as part of that certification, which I was surprised by. I don't know if that's across the board or just because we were a medical device, but I don't think it was because we were a medical device. I think it was part of the ISO standard. But fortunately, we had it because we were a medical device, but we wouldn't have otherwise.
That's really interesting. You said that's ISO 6061? Oh.
I lost your audio somehow.
Oh,
there you go.
No.
Yeah.
Which ISO standard did you say that was?
That was ISO 60601-1.
Okay. Is there a lot
Yeah.
of background noise, or is this okay?
It's okay. I can hear you.
Okay, good. All right. Anybody else want to jump in?
Yeah, happy to. Can you all hear me okay? Perfect.
Thanks.
So on the fertilizer side, so we're selling a liquid fertilizer product. We actually managed to get it organic certified nationally, which was really helpful. So that's called OMRI, O-M-R-I certification. It's basically a third party that the USDA recognizes as an organic certifier, which was really helpful. It was a really long process and pretty painful. So it took us probably about like 9-10 months or so to finally get that certification. But something that was helpful for us is the certification counts for all of our systems and our company. So as we start scaling our digestion systems, we don't need to get recertified for every single system. It actually basically encompasses our entire company and our process. So that was something on the certification side that was really helpful.
That's awesome. Thank you for sharing, Dylan. And that is a really important question to ask as you go through your certification process with your given regulator or testing lab or whatever it is. What does the extent of their certification cover? And also what type of design changes can be made that certification would continue to cover? We'll talk a little bit more about that in a few slides.
Exactly. And I'll quickly add there as well, Matt, on the opposite end of the spectrum, we're currently working to get our carbon diversion certified. So get certified carbon credits that we're generating. That's also pretty like a little bit of a manual, slightly just busy process to get through. And they're kind of the opposite end where they actually want to certify each individual system. And we could possibly like group systems together, but they wouldn't allow us to basically like certify our process in our company. So that's something we've kind of seen both ends of the spectrum where we have one certification that encompasses everything and another. Luckily, the second one we're not really reliant on. It's just like an additional revenue stream we can build out. But that's something we definitely did and are still trying to work through a little bit.
That's very good. Very good point. Very good to know. And it reminds me too that is another one that oftentimes manufacturers will carry is CGMP, Certified Good Manufacturing Practices. And it is strange because it is a sort of voluntary certification process in a lot of ways, but it's also oftentimes a first step question that certain food certifications will carry is, does the manufacturer have this? Okay, that's step one. Now, do all of the ingredients that you're sourcing for the product have their own certifications showing that they are approved materials and made in approved environments? Anybody else want to jump in? No? We can feel free to interrupt or jump out because we're going to talk about some of this stuff in the upcoming slides here. But this is one thing. Who issues each product/design certification? And this can vary depending on the standard that you're trying to meet. It could be a specific testing lab. It could be a government organization like the FCC. or it could be a corporation like Bluetooth. And then who carries the certification? Is it the product itself, like a UL stamp on a product, or is it the factory that carries it? Sometimes it can be both. So RoHS is something that a factory will carry, but then it's also can be stamped onto your board if it comes out of a RoHS facility. So these are things that you'll just have to question and get a handle on based on your own particular environments. Great discussion from everybody about the lead times and how it can dramatically vary, and it can also vary dramatically depending on how prepared you are for it. So it's best to start the conversations early and figure it out. Also consider what design and or manufacturing maturity you need in order to get a specific type of certification or test. So can you use a design validation prototype, or does it need to be a production validation prototype in order to be certified? The difference there would be a DVT prototype might have sort of 3D printed enclosures on it, and that might be good enough for you to get certain certifications, potentially even certain UL certifications. However, if you want to get maybe an FCC certification or an FDA certification, you would need to have a production validation prototype. And it might also, you'll also need to ask for your particular certification, how many samples do they need to test in order to certify a given design? Is it just one, or do they need a representative sample based on how many you are going to ultimately produce, a la like the AQL sampling strategy that we had talked about? Definitely keep in mind what documentation you'll need in order to get certifications. That was a great point from Mara about ISO 60601, that you have to have that sort of document, that quality management documentation in place in order to even finalize your certification. We talked about the samples, and then does the certification require a representative in a foreign country? That is a really good question to ask. So how to obtain a certification? It's very similar to how you would ultimately get your product manufactured. I recommend getting multiple quotes, talking to multiple vendors. I'd also recommend getting, quotes and having discussions with people outside of just testing laboratories. Sort of when the only tool you have is a hammer, every problem looks like a nail situation that you don't want to find yourself a part of. We covered sort of all of the questions that you'd want to ask earlier in this. Determine your lead time, select the certification lab to hire, submit your samples and all of the paperwork that they require, which might be significant. You'll get your initial test results, additional inspection, and then you'll have to get your final paperwork and certification numbers before you can ultimately put that on your product. Now, that can be something important for your ultimate design finalization. Is if you need to mark every single product with a certification label, you want to make sure that you have both the space and the material on the product where you intend to put that label that is suitable for a labeling process that your manufacturer has in-house. So there's a local company, Mecco Marking, that actually does explicitly just part marking systems. They do pin marking and laser marking. And one of their biggest customers is the automotive industry, because every component in an automobile should have a label on it that corresponds to when it was made, who made it, and where it falls in their quality management system for ultimate sort of recall and traceability. So it can be a very big industry. It can also be something that is molded directly into your tooling, but that would require your tooling to either be modified or finalized only after you have that certification. So common questions to ask. ask your factory or your contract manufacturer if they can do pre-scans or pre-certification assessments. Also ask your testing laboratory if they will accept any type of pre-scans or pre-certifications or perform any of that, so that you can make sure that you finalize the critical aspects of your design and minimize your ultimate lead time or cost in getting that certification. Now, also consider how final your design is and your critical performance specifications, because if something needs to change on it and it's a minor change, that might require recertification in some, according to some standards and some regulations, or it might not. So before you really finalize your production plan, it's a good idea to figure out what your certification plan is. Significant changes would definitely require recertification, which could mean involve producing new samples and testing them again and paying for the paperwork and everything associated with that. This is something that a lot of companies that have electronics components are running into more and more and more. And even we've had local, larger, more mature companies reach out to us for advice on what to do, because a part, like a simple part, of voltage regulator that was on their board suddenly was no longer available, and they couldn't produce orders for a specific customer because the lead time on that part was 52 weeks. And voltage regulators are not a specialized component. There's plenty of them on the market, but understanding what specific pinout that voltage regulator has is really important, because there might be a dozen different manufacturers that make a voltage regulator with the specifications you need and that specific pinout. So you won't need to change your board design to swap out between any one of those dozen different manufacturers. However, if you have a different pinout that only has 2 manufacturers that make voltage regulators that meet those specs, and both of them are out of stock, then you have to consider alternative ways to source that one specific component, or what the cost of it would be to redesign your board and relay out your board so that you can use the more commonly available components. This is a huge thing that more and more companies are running into with all of the supply chain issues that are coming up now. So once you actually get your certification, labeling is a huge consideration. You're going to go to all this effort in getting your product tested and approved and your certification and the number on file, but if it's not ultimately visible on every single product and every single piece of packaging, you might have gone through all of that for naught. And labeling doesn't just encompass certifications, it can also be for your own benefit with identifying SKUs or stock keeping units. And these are variations of a product that identify it from one to another. Having that done in such a way that identifies the product and matches all the way down to your bill of materials and into your inventory forecasting systems are really, really useful. And it also makes the whole certification process much cleaner. Barcodes, QR codes, and RFID tags are oftentimes also used in managing these types of information systems. Don't forget about marketing and your brand identity. So if you go to the trouble of having a trademark and building a brand, you'll want to make sure that that is visible on your product. For instance, I once saw a Smirnoff ad that used a perfectly clear ice cube, and it had my molds in the background, but my molds didn't have my brand name molded directly into the product. So somebody could do that, and I would have no way of proving that or getting sort of the free advertising out of visibility of that product in the background. Missed opportunity there. Also, don't forget about warnings and safety considerations like Prop 65 or suffocation warnings. Even if the internal components of your product have plastic bags, oftentimes any distributor would require that plastic bag, if it's over a certain size that like a baby's head could fit into it, would require you to put, not intended for children, potential suffocation hazard, written right on that bag. Operating and setup instructions are a huge thing to not neglect, and that was one of those benefits of starting your bill of process early, because that can really give you a head start on your technical documentation that ultimately should go out with the product to your customer. And then if you're licensing intellectual property, check and make sure that if you have any sort of labeling requirements from your licensor of that intellectual property. I highly recommend looking at all of the products in your life and seeing sort of where their certification labels are on not only the product itself, but also the packaging. Here's an example of like a Fitbit, and you can see their serial number, a MAC address, which I guess means that this product has like a SIM card in it and data connectivity of its own. There's the FCC ID, which means that it's registered with the FCC. The IC number, which I think is a European Union equivalent to an FCC number. The model number, which is interesting, and also something that is valuable to sort of institute earlier on than you might think, is, so this is a Fitbit Versa 2, which is what the consumer market knows it as, but the specific model number for that product is listed here. There's also, barcodes are basically a laser scannable serial number that's associated with that. We have an IEC label here. There's also this contains like a lithium ion battery, so don't recycle it in a conventional, or don't throw it away in a conventional waste disposal system. There's a CE mark, recycling code. There's a lot of information contained in these labels. So we talked about some of this just on the last slide here, but a part number used for tracking individual components on your BOM, a stock keeping unit, which would refer to sort of one variation of a BOM that identifies a specific set of components or a specific variant of maybe sizes or colors. Serial number, which can be dumb or smart, and we'll talk about that next, that identifies what a specific individual unit of the product. This is sort of critical for that device history record. If you're a medical device, that's one way to trace your product back in the event of a recall or an audit. And then part mark is a physical mark on the product to record its number and batch. There's a lot of different ways to do that. Like I said, there's even, you might have seen, there's a little circle a lot of times on injection molded parts, which has every month of the year and then year of it, and then another sort of unique identifier which can be indexed. So every time they run a new batch, they can tell what batch that was produced by without having to modify the tool. There's a lot of little industry standards like that, especially if you're manufacturing overseas, if you don't specify that, then it won't be included. So consider smart numbering versus dumb numbering of what your products are. A smart numbering on that product might require an encoder. So this could be the modern day. You could use a QR code to embed a lot of information because it ultimately just links back to a website. But Amazon is doing something with this called transparency, and it's basically their attempt at creating their own intellectual property protection system. So they will issue a unique random number to register your product in their database. And so nobody knows what that product's actual transparency code is except for them. That way they can identify frauds and counterfeits. But nobody will know that except for them because they have the decoder of it. A dumb numbering system can actually be super easy for you to just use because you can then identify it once you know the process. Actually, a dumb number would be totally random, but a basic smart one, you can identify a lot of information on it if you just know the what each portion of that code means. The downside of that is it can be sort of, once somebody figures out what your pattern is, they can create very authentic fakes. So now talking about distribution, there's a lot of industry jargon around distribution, which is helpful to know so that you can ask the right questions of suppliers whenever you're working for it. So operations in general covers all of the individual tasks associated with shipping your product, and that can be at every stage in its distribution. Logistics is the general plan around how both the information and the materials are going to move through the system. Reverse logistics are shipping your product back from the customer. So that's, includes RMA, like RMA processes might be a potential of reverse logistics. Do you want to approve whether or not a customer is allowed to send a product back before you then enter it into your system? How do you treat and deal with the quarantine materials after they're returned to you? Do you refurbish them and sell them, recycle them, dispose of them? All of that side of things. Distribution is the process of moving materials from the manufacturing location to the customer. And that might, depending on your logistics plan, have multiple different steps in the process. And shipping is a general term, which can oftentimes lead to confusion because you will ultimately need to coordinate shipping from, in my case, my factory in China to the port, and then that is coordinated by a different person than once it's on the ship, after it gets through the port. And then once it gets off the ship, there's a different step that gets it to a fulfillment or distribution center before it then goes out for a sort of last mile delivery. And then you can have even another additional step in that shipping process of using a last mile carrier if you can't accept freight shipments. Common distribution steps and some important terminology is the FOB is a acronym that you'll see probably a lot of times as you begin to talk to factories, and it stands for free on board. And that means that your factory is going to actually handle the logistics of getting your product out of its doors and onto a freight or distribution system, a shipping system. XWorks or EXW means that your factory's work is done as soon as they complete it. And it will sit in their factory unless you arrange for all of the logistics around transporting that to your ultimate destination, whether that is your own distribution facility or direct to your end customer. Some things to consider, and these numbers are a bit outdated now as logistics have gone even more crazy, but ocean freight, I'd say, can range anywhere from 14 to 45 days. Air freight, I'd say, can range anywhere from 1 to probably 7 days. As you might expect, the faster you intend to ship something, the more expensive it will be. Keep in mind that customs and international boundaries, anytime your product crosses a boundary, there is the opportunity and potentially the requirement that the product will be checked for certifications, labeling, and other sorts of tariff codes. It's very common to hire a customs broker in order to make sure that you're meeting these requirements, including all of the fees associated with customs, tariffs, duties, VATs, handling and storage. I will add to this that we'll cover it on this one. So the final delivery to your customer, consider whether you're going with a direct to consumer model, or are you going to be shipping to a distributor or a retailer? This might add an additional barrier and benefit to having a very well defined labeling and marking system for your product. And if you end up going through a distribution center or a warehouse, you might run into additional layers of complexity. So Amazon is a common example of this. Amazon has the opportunity for you to sell merchant fulfilled, which means that I would ship my product to Amazon customers, or fulfilled by Amazon, which means that I have to ship my product to Amazon. Amazon has to receive it, take it out of the box, know what it is from the labeling that's on the outside of the box, put it on their shelves, so that whenever Amazon gets the order, they can go to that shelf, pick the right product off the shelf, put it in their packaging, and ship it to the end customer. Those additional steps result in additional fees and then also potential penalties if you don't abide by their specific systems. So Amazon requires you to have a GTIN number, which is a UPC code, and that's what we oftentimes associate it as a barcode. That is a unique identifier in this GTIN network to say that this product, this number represents this product and no other product anywhere else. That goes back to retailers of all days, because if you think of your product being sold in like a Target or in a convenience store, they needed a system so that they could barcode it and identify that your product is not going to be confused for a candy bar. Whenever you're at a gas station and they sell, automotive products and candy bars. Amazon now has its own thing, which they call the ASIN, or Amazon serial index number or something like that, that they're using to also attempt to replace sort of like the GTIN numbers for people who sell just explicitly on Amazon. But the additional fees and distribution costs that I was talking about, there's oftentimes loading costs at the port. There's transportation costs at every step in the way. There are insurance costs, which can be different depending on, there's sea insurance, but then there's also sort of the land freight insurance, because oftentimes there's a handoff once your container gets to the port. Fees and duties and customs, but then something that's not really covered in this is if you're going with a third-party distribution system, like an Amazon fulfilled by Amazon, they will oftentimes break it into storage, pick and pack, and shipping fees. So you're going to pay to store your product in the interim at an Amazon fulfillment warehouse based on how much either floor space or volume your product takes up, or the total volume of all of your products take up. Every time they ship an order for you, they call that a pick and pack fee. So if they have to pick one of your products off the shelf, they'll charge you one fee, 20 cents. But if they pick two, they'll charge you 20 cents twice. And then there's oftentimes a packing fee associated with that too, which covers the cost of like the Amazon box and the person putting it in the Amazon box. And then they'll still charge you the shipping fee. Oftentimes, if you go with a third-party distributor like that, for instance, my product, if I ship 12 of my products, which is the most that I can fit into a regular box before it gets an overweight surcharge, it costs me about $45 to ship that in the US. It costs me about $10 to ship it to Amazon. And then it costs me probably like 10 cents a month to store it at Amazon. But then whenever Amazon ships it to my end customer, it costs me an average of $12 to ship my product to an end customer. But when using Amazon, they only charge me $9 a customer. So oftentimes, if you're at the right scale, you might actually be able to save money by using a third-party fulfillment service over doing it yourself. And that gets to be a very complex problem to solve. I'm going to save these unless anybody has any particular burning desire to talk about or ask about any of these logistics and shipping questions. We can come back to it at the end. So we have about 15 minutes left. All right. If not, other considerations for scale: forecasting your order timeline. There is a lot of things to consider when forecasting and ordering. So seasonality, how much do you need in order to meet your customer demands at a given time in the year? How long does it take for you to order and get the product to you? Is there a minimum order quantity associated with ordering that product that would require a significant outlay of cash? Are you saving up that cash ahead of time so that you're prepared to place that? Or have you lined up other opportunities for financing in order to pay for that when you need it? What is the total time from placing a PO to receiving the parts or receiving the product? Other considerations to include, so your sell-through rate is a score that oftentimes you'll get on Amazon because they don't want to carry a lot of inventory there, and they will penalize you if you end up trying to simplify your operations by shipping an entire year's worth of supply to them. You will get penalized in their algorithm. So an MRP or materials resource planning tool can help you with, or manufacturing resource planning tool can help you with both automating this process, but also organizing it. It's oftentimes, like a lot of the other software tools out there, you can do it all manually. You can pay for a limited functionality, low-cost software as a subscription tool, or you can go to a full enterprise software system. But the adoption of any one of those tools, the success of that adoption is going to hinge completely on your own understanding of your operations. So now moving on to considering any type of project that you might want to undergo, either to grow your business or make a design change to your product or optimize your production. I like this decision matrix to consider. So it's a classic 4-quadrant matrix there with ROI on the left side and then risk or cost on the x-axis. So ideally, what you're trying to identify is products or projects that will have a high ROI and either a low cost or a low risk in terms of achieving the desired outcome. So you'd want to focus on these first because they're going to provide you with the quickest, most sure success. The projects that have a high ROI, but also potentially a high cost and a high risk of failure are things that you will want to assess based on your budget and the amount of resources that you have available to dedicate to them. But it's best to limit these projects to only the most potentially beneficial ones in terms of your ultimate outcome. The low ROI but low risk, low cost projects are ones that you should tackle, but they should not take precedent over higher ROI projects. And these are also great ones to delegate or outsource if the resources are available to make sure that they can also achieve these projects without requiring additional burden on your time. Anything that has a low ROI and a high cost or high risk of failure is something that you should not do. Now, the Eisenhower decision matrix is a very popularized version of this, which I'd recommend looking up. So other considerations when asking yourself if you're ready to scale up, the MRL and the TRL is a great framework for identifying potential shortcomings before you decide, is your project ready for scaling up as one of those moonshot projects, or will it result in maybe the ROI is there, but it's also a high risk or a high cost of failure. So it pushes it from being something that you should absolutely be focused on right now into the 1 to 2 moonshot projects per year. And then the business maturity too, which is, we talked about the commercial readiness level factor, which early on, you're just trying to make sure that you have a significant pain point that people are willing to pay, and that you can solve that with your product. But later on, it's going to be about your demand. So if you don't have a certain demand, then it's going to be difficult for you to justify the cost of increasing production when it comes to paying for and financing tooling, for instance, if you don't have a steady and reliable source of revenue coming in from your product sales. Now, the book has plenty of more topics on this to cover, everything from customer support, including warranties and recalls, as well as other mass production considerations like how do you implement continuous improvement projects, cost down, how do you deal with audits like an FDA audit for your quality management system, and then also equipment maintenance and field servicing, as well as launching your next product or version controls or improved versions. So we'll do a quick recap of the initial product stage assessment. So this is a simplified version of the MRL, which you can use to sort of identify what stage your prototype is and how important it is to move on to the next one based on if your demand is there for production at a given size or a scale. The full MRL assessment is useful in identifying what specific sub-threads you might want to work on based on your manufacturing level, whether it is sort of your design, your material selection, your manufacturing method selection, your quality management, your manufacturing workforce, and so on. These all here's an example of a bunch of projects which you might potentially be able to undertake that could improve your MRL level. This is especially great for those of you who received one of the Next Core grants. These are great ideas for what could potentially define an eligible product for those grant funding. Keep in mind that you can do multiple projects using that funding, and that we will need to see, ideally by Friday, which a project roadmap that will explain what you intend to do. If you have a contract manufacturer or a service provider in mind who can perform the scope of work, and then what MRL threads you think that this would help you impact in order to advance the maturity of your design. So some more examples. I will say that we also, through the Scalable Innovation Program at InnovationWorks, have funding available for the similar type of project work. You can go to scalableinnovation.org/scalable funds to read more about the scalable grant funds that we have. But the general process is that you'll need to sort of submit your idea, define a scope of work, which is basically all of the same as this roadmap. So it's useful for everybody to go through, in my opinion. Will help you to identify, or you can have your own local manufacturer identified already. And then once the project actually works, the scalable grant, instead of upfront, a scalable grant is a reimbursement grant. So you'll have to perform the work and then seek reimbursement for the eligible expenses. So we've got about 5 minutes left. Does anybody want to discuss anything related to logistics or funding for the current stage of product or prototype or production that you are at? Okay. Well, if not, I would encourage you to take a look at the book, try to complete the project roadmap, even if it's just for your own use. Feel free to schedule a meeting with me if you would like some help reviewing that. I'd also ask that you complete our manufacturing tour survey if you're interested in going on tours of a local factory, and check out Anna Thornton's book from Factory Tour Checklist from the book and the product realization. All the topics that we talked about today and more are covered in chapters 15, 16, 18, and 19 in her book, Product Realization, going from 1 to a million. Now, also, don't forget to fill out a feedback survey for this and any other session that you thought would be interested. And also, let me know if you ended up watching this recording after the fact. And again, my office hours will be available on an ongoing basis. Here's just a sample list of some things that we might be able to help you with if you wanted to put some time on my calendar. So if we don't have any questions, I really appreciate you guys taking the time and joining me for this ride. Thank you, Stephanie. I appreciate it. I'm glad it was helpful.
Yeah, I just wanted to. There's. Hello.
What's that?
I can just hear my voice. I'll just power through it. Yeah, this session was great, and it's really formed the basis of core foundational understanding on many of the topics. So really appreciate it. Hadn't really thought about many of the things that you covered today. So it was really helpful, and look forward to rewatching a lot of these recordings if and when we get to the point of you said some really good things about shipping and logistics, which is great, but they don't impact us right now. So we are not going to do anything about it, but when it's time, we'll rewatch the lectures again. So thanks for also making it publicly available.
Thanks, Rowan. I really appreciate that, and it's very validating because that is something that I've come across in these last 4 years that I've been doing this with IW. That when you get a group of people to sit down and listen to this type of stuff, and they're not ready to hear it at that moment, it goes in one ear and out the other, and then it's gone for when they actually need it. So I hope this is a valuable resource.
Yeah, there's lots of unknown unknowns, and now these become known unknowns, and then we know that you just need to go out there and think about these things when the time is right.
Awesome. Thank you so much. All right. Well, if nobody has anything else for the group, I hope everybody has a great holiday and wrap up their year. Put a nice bow on it.